We live in a universe that seems unusually hospitable. The physical constants are precisely tuned. The four fundamental forces operate in just the right proportions. Matter clumps into stars, stars forge elements, and planets orbit just far enough from suns to host liquid water. Is this all just a remarkable coincidence? Or is there something deeper going on? Welcome back to Infinity Beyond. In this episode, we delve into one of the most controversial and thought-provoking ideas in all of science, the Anthropic Principle. At its core, the Anthropic Principle is a simple observation with profound implications. The universe must be compatible with the conscious beings who observe it. But from that seemingly harmless statement, a host of scientific and philosophical theories have emerged, ranging from the strictly logical to the almost mystical. Let's break it down. There are two main versions of the Anthropic Principle. The weak Anthropic Principle, UAP, this version says, we observe the universe to be compatible with life, because otherwise we wouldn't be here to observe it. That sounds tautological, but it actually matters in cosmology. For example, it helps explain why certain constants, like the cosmological constant, fall within a narrow life-permitting range. In other words, out of all possible universes, we happen to be in one that supports observers, because we are observers. But then there's the stronger version, the strong Anthropic Principle, SAP. This one takes a bolder step. It says, the universe must have properties that allow life to emerge, at some point, in some form. This suggests a deeper necessity, that the universe is somehow compelled to permit life. Some interpretations of this principle verge on teleological or even theological, implying purpose, intention, or design behind the laws of physics. Of course, most scientific discussions avoid this metaphysical leap, focusing instead on the selection effects at play. So where does modern physics stand? Interestingly, string theory and cosmological inflation have opened the door to new ways of thinking. String theory predicts a vast landscape of possible vacuum states, each corresponding to a different universe with its own physical constants and laws. In this multiverse landscape, most universes are lifeless, chaotic, or brief. But a tiny fraction, like ours, just happen to have the right ingredients. And if all of these universes exist in a grand multiverse, then our universe's apparent fine-tuning might simply be a selection bias. We're here because we could be. Still, the implications are huge. It means that many of the deepest questions in science might not have single answers, just a cosmic lottery of possibilities. Our constants, our particles, even our laws of physics could be accidental outcomes in a vast probabilistic framework. This is a radical shift. Traditionally, physicists hoped that all constants could be derived from first principles, unbreakable symmetries, or deep mathematical truths. But the Anthropic Principle suggests some constants may simply be what they are, because if they were different, we wouldn't be around to ask about them. Of course, this idea is not without its critics. Many physicists dislike the Anthropic Principle because it seems to undermine the predictive power of science. If every observation can be explained by "we exist because we can," then where's the testable theory? Others argue that it encourages lazy thinking, a way to avoid digging deeper into the true origins of the universe's constants. And yet we can't ignore the coincidences. Why is the cosmological constant so small, allowing galaxies to form? Why do protons and neutrons have such similar masses? Why does the strong nuclear force allow stable nuclei, but not too strong to prevent fusion? Time and again we find that tiny changes in fundamental constants would render the universe sterile. The Anthropic Principle may not provide all the answers, but it does pose a necessary constraint. Whatever theories we build, they must be compatible with observers, with us. Whether that reflects an underlying logic of the cosmos or merely the survivorship bias of being alive in a rare habitable universe, remains a topic of fierce debate. And perhaps that's what makes the anthropic principle so fascinating. It blurs the lines between science and philosophy, between what is and what could have been. It forces us to ask not only how the universe works, but why. Why does this universe have the properties that it does? Why do we exist at all? Why are the laws of physics not just stable, but life-permitting? Whether you see it as coincidence, consequence, or cosmic design, the anthropic principle challenges us to reflect on our place in a reality that seems, against all odds, tailored for life.